So let's get started. So composition of functions. Fancy talk for let's take one function and mix it in with another one and see what we get. Of course, it's not that simple. There's an order that's going to matter, okay? And when we do the mixing, we have to follow all of our rules in algebra. Right, Chase? Okay, so first thing I want you guys to write in big letters is that order matters, okay? And we're going to go against what we're so used to doing when we read and we open a book and look at the top of a page and read left to right. In composition of functions, we always, not sometimes, always work right to left, okay? So we're going to see notation that looks like this. Now, this example right here is using letters F and G, which are the most common ones, but we see all different letters. What really matters is the order that they're written in, which in turn is the order we work with them. And the way we say this little teeny tiny open circle is not an O, it's like the word of. This is F of G of X, also written as F of G of X. These are same type of work, same order of operations here, but they're just two different notations, okay? What I want to do first, before we go too deep into it, is to prove to you that order matters. We're going to take two functions. We're given f of x and g of x, and we are going to do f of g of x and then g of f of x. And this is going to prove that the order we work with these functions is going to make a difference. Oh, okay. Sorry. We rearranged for you so that you would have room to sit together, but okay, no big deal. We're on page 75, sweetie. All right, so here we have, look. We have f of g of x. Let's do that one first. Okay, and then we'll do g of f of x. Okay, now like I said, we always work right to left. So we will start with g of x and plug it into f of x. Right to left. So this means we start with g of x. Remember, g of x and f of x are given. I'm going to take what g of x equals, and I'm going to plug it in to f of x, mixing them together, okay? And when we plug things in, numbers, letters, binomials, into another equation, where do you think we're going to put it? In the x, right, Remy? I'm going to take 4 minus x, and I'm going to put it right there. So I'm going to take out x and plug in 4 minus x. Since there's a 3 in front, that means I'm going to put what I'm plugging in parentheses. So I'm going to start writing 3, and then parentheses. I'm taking out this x, plugging in 4 minus x, minus 5. Right? And then you clean it up. We distribute. And combine like terms. We're not solving an equation, we're simplifying, okay? So 12 minus 5 is 7, and then we have the minus 3x. You could write it just like that, or you could write it as negative 3x plus 7. Either way is fine, okay? So when we mix these two functions together in this specific order, it simplifies down to that, okay? Let's see what happens when we do a different order, same functions. F of x into g of x. So I'm going to take all of f of x, this whole thing, and plug it in to g of x. Now let's note, let me tell you guys something, which we'll see in a minute, but I want to make sure we're clear on it right from the beginning. When I plug my initial function into the receiving function, that receiving function might have more than one x. It could have x squared minus 4x plus 5 or something. Everywhere you see an x, you would plug in whatever function you're plugging in, okay? Just like you would with a number, okay? So f of x is going to go in where x is. Because there is a negative or a minus in front of it, I'm going to put my f of x in parentheses. Okay? That negative in front means I'm going to be distributing. And and then combine like terms. This could be 9 minus 3x or negative 3x plus 9, either way. You know what I mean? Okay, great question. That's okay, because if you thought it, others might have thought it too. Why are we not multiplying the function that's in parentheses by 4? Because it's separated by the negative, okay? So another way of thinking of that is that could be 4 with a negative 1, right? So order of operations is to multiply and then combine like terms. Yeah, sure. Okay, now let's talk about the domain of these two functions. Hi. Oh, okay. All right, perfect. Haley. Do you want to move over here? We've already planned for you. Hi, welcome.
Thank you.
Yeah. No problem. No problem at all. Okay. So, welcome. So, the domain. Okay, so one of the things you're going to have to do, so we have two different answers. I just proved to you that order matters, okay? So listen. If I asked you what is the domain of these, you would say all real numbers, okay? There's no fractions or radicals. X can be any number it wants to be, okay? I have a little phrase I say, no fraction, no radical, no problem. If there's no fraction in the problem, if there's no radical in the problem, then there's no problem, okay? So the domain for both of these would be all real numbers. I want you guys to add in this little space up here some notes about restrictions. Let's talk about when we do have a problem. Restrictions on the domain. When do we have a problem? Well, I just said my little phrase. No fraction, no radical, no problem. So if we have a fraction, y'all, what do we know that a fraction can never have in its denominator? You can have a negative in a denominator. 0. Is that you, Jayla? May, thank you. Guys, you can never have a 0 in your denominator. We should know that. We've talked about that so many times. Never, ever can you have a 0 in your denominator. When in doubt, ask your calculator. They're really smart. If you do 1 divided by 0 or any number divided by 0, you're going to get an error, divide by 0. You can't do that, okay? You can never have a 0 in a denominator. So anything that would make your fractions denominator 0 is a restriction on the domain. It's a number that we don't include in the domain. The other thing is a even number root, okay? A square root, we can never have negatives under it. I told you a while ago when we did like 1 or 2 days with imaginary numbers that we wouldn't see them again. We're still there. We're talking about real numbers only. So anytime you have a radical with an even number root, 2 is our most common one, we can't have negative numbers. We didn't mean to put an equal sign there. Let me just make it like this. What we would say is that x has to be greater than or equal to 0. Why the equal to? Because we know anything greater than 0 is positive, so we're excluding the negatives. But why are we including the 0? Well, the square root of 0 is a perfectly valid problem. The square root of 0 is 0. Again, ask your calculator. It's very smart. If you do the square root of 0 and it lets you do it, that means it's okay. All right? The square root of 0 is 0. So that's why we say that whatever's under the radical can equal 0 or any positive number. No negatives. So these are the two restrictions we see. But like I just showed you in this example, there were no fractions, no radicals, no problems. Both of these would have a domain of all real numbers. Okay? Good? Let's go to the next one. We're not going to do all of these. I think we're going to do B and C here. Okay? Now, in this problem, they give us f of x, they give us g of x, and they give us h of x. And then we'll just do whatever it's asking us to do. In this first example, working right to left, we're going to take f of x and plug it into g of x. So I'm going to take all of f of x, and I'm going to plug it into g of x. Where does it get plugged in? For x, right here. So, guys, if I told you that f of x was 5, you would all, like if I said, here's an equation, x equals 5. You can all graduate right now. Every single one of you. You're done with school if you can get this right. What would you do with this 5? You plug it in for x, right? None of you would get this wrong. Not a single one of you. You would take that 5 and you would take out this x and put the 5 in, right? And you'd get 1/7. The reason I'm saying something so obnoxious here is a common mistake that is made. Not here. Nobody makes a mistake here, but this is the same idea. When you go to plug all this in, you don't leave this x there. So I have a lot of people who are like, oh, do I multiply this x by this? No, you're replacing this x with that. Hello, can you sit there today? What? Okay, so where was I? So what the point I'm trying to make here is that when I plug f of x into g of x, I take this x out. And I plug that f of x in. I'm not putting it in parentheses because there's nothing around it. I'm not squaring it. There's not a negative in front. There's not a number in front that I have to distribute. So look, I just took out x for this 76, and it replaced it with this right here. And that's it. There's nothing I can do to simplify that. That's it. There's no other work to do. That's the answer. But what is the domain? No fraction, no radical, no problem. Wait, we have a problem because we have a fraction. That means your domain is not all real numbers. There's something or some things that x can't be. So anything that makes your denominator 0 is a restriction. We have to factor. Factoring never goes away. Okay? What two numbers? Multiply to get 2, add to get -3. -2, -1 in any order. So, oh my goodness. Hello. Okay, thank you. This person is not in my class. Oh. I don't know. Is your name Fabio? Oh, okay. Did your brother go to school? Oh, Christian, I have him. Okay. Okay. So what can x not be? 1 or 2, right? If I put a 2 in here, I get a 0. 0's bad. If I put a 1 in here, I get a 0. 0's bad. So x can be anything but those two numbers. In the homework, I'm fine with you just writing it like that, but don't forget how to do stuff you're supposed to already know how to do, which is interval notation. So let me just review that real quick. How would I write my domain in interval notation? Get to 1. Yes. Nope. We have from 1 to 2. Remember, there's numbers in between 1 and 2. So think of it as on the number line, these two are excluded, but everything else. And there is stuff in between 1 and 2. So remember using that like U, or you could use commas, jumps over 1, jumps over 2. Good, Zach? On that one? You're good? Okay. All right. Let's do one more of these. H of x into f of x. So h of x is right here. I'm going to take it and I'm going to plug it in for f of x. Look, guys, there's 2 x's in here. I'm going to put it in both places. So the square root of x, since I'm squaring it, I'm going to put it in parentheses. Minus 3 times the square root of x. Why don't I have parentheses there? Because 3 times the square root of x is represented by. No. I feel like I'm getting punked a little bit, like it's a joke. Like how many times the door, okay? Anyway, let's simplify it. When I square a square root, remember they're opposites of each other. That just gives us x. You gotta know that. Remember, if you have a cube root, you cube it, you're just left with it. They're opposites. And there's nothing else we can do. That's as simplified as we can do it. No fraction, no radical, no problem. We have a radical, we have a problem. Problem is a restriction on our domain. So we would say x is greater than or equal to 0. If you wrote this in interval notation, it would be from 0, including it, right, to infinity. So either one of those is fine, just you should know both. Okay? Good so far? These are the easiest ones. They're so easy, I'm not even going to do them all. What we're going to do now is do some composition of functions using graphs. So look at A. Working right to left, we start with g of 3 and plug it into f. So there's usually, what have we seen in place of the 3 in all the other problems? X. So 3 must represent what? X. 3 is x. So we have a graph of f of x and a graph of g of x. So we're going to start at g of 3, which is on the x-axis, go to 3, find y. So when x is 3, y is 1. So what I have now is f of 1. You just keep going. So I've got g of 3 is 1. Now I find f of 1, and whatever I get is my final answer. So in the f graph, go to x is 1, find your y value. Final answer would be 2. Guys, come on. G of 1 into f. Go to my g graph, find x is 1, y is 3. So I'm doing f of 3 now. Go to my f graph, over to 3. Y value is 2 again. That's just a coincidence. They're not always 2. Okay. Okay. This looks like, looks can be deceiving. We see parentheses and brackets of what is going on. This is easy. We'll start with g of 4, plug it into f. So g of 4 is what? 0, right? G of 4 is 0. And then go to your f graph. X is 0, y is 4. Then there's a time symbol. Let's do this one. F of 1, notice it's starting with f. Okay, we can handle that. F of 1 is 2. And then we go to the g graph. G of 2 is also 2. Multiply them together. 8 is your final answer. Let's do one more of these, because we hate fractions. They're so scary. Go to the f graph to -1. F of -1 would be what? 6. So we have a 6 in our numerator. G of 3 into f. So g of 3 is 1. F of 1 is 2. And then simplify would be 3. Easy peasy? Good? Okay. If you're not finding those easy, you just missed something. So if you need help, I will come explain it to you. We're almost done. We have 2 more examples to do, example 4 and example 6. So I feel like those last ones are kind of like what I call freebies. I don't think many people get them wrong, okay? Same with these, all right? This looks like it might be hard, but it's not. We're doing decomposition. So we're basically doing the opposite. H of x has been created. These are all my h of x functions. H of x was created by doing f of g of x. H of x was created by taking a g of x function and then plugging it into f of x, just like we did on all the others. So g of x is on the inside, right? And then f of x would be on the outside. F of x can kind of be thought of as your parent function as well. So let me show you this first one, and then I'll explain how you can make sure you got it right. Inside would be x plus 3. Outside would be x squared. Check it. If I put g of x into f of x, I would take out this x, and put x plus 3 in parentheses, and I would get that. This one is the x minus 5 in the denominator. The parent function, we haven't done them in a while, but it's those rational functions. Think about it. If I take x minus 5 and plug it into this function, it would be 1 over x minus 5. What's on the inside in C? X plus 2. Remy, what's on the outside? A radical x. Look at this one closely. This is what's getting plugged in, right? X minus 2 is in place of x. Right? We would take x minus 2 and put it in there and there in parentheses, and you would have that. So decomposing is just figuring out what's on the inside and what's on the outside. Okay? Example 6, last one. You know, when we have to do word problems, we all kind of like, we hate them, right? And these are kind of word problems, but it's really more about understanding function notation, okay? So when I start reading these problems, I start underlining things like I've been modeling for you every time we do a word problem. So let me just read for a second. Jim plants wheat on his farm in Kansas. Guys, please don't talk. The function W of A gives the amount of wheat in bushels that he expects to harvest if he plants on A acres of land. So wheat and then number of acres, okay? So that helps me kind of organize what W of A means. That's my way of doing it. If you are fine just reading it or underlining, that's fine. Okay, let's keep going because I can look ahead and see there's another one, and then we're going to be mixing them together. When the wheat is harvested, Jim can calculate the amount of money. Amount of money is M in dollars that he will earn from selling W bushels of wheat. So W is number of bushels, and then N is your money. Okay. So what would W of 5 equals 275? Well, 5 acres, right? This is my A, W of A. 5 acres will yield 275, what was it called? Bushels. I have to go back up to the word problem a lot when I do a word problem to figure out how to like label something or what did I miss with that letter. Remember, you can always go back and look at it, okay? Maybe you didn't underline something in the beginning that would have been helpful. So this is saying 5 acres will give him 275 bushels, maybe I should say, of wheat to help you see it, okay? That's basically what it said in that second sentence, okay? Let's do the M one. M of 65. So what's in there is the W, right? 65 is number of bushels. So 65 bushels of wheat what would M of W represent? What would 550 be? Amount of money in dollars. So we'd get him $550, right? Those two are kind of basic function notation that we use all the time. Our last one is composition, putting them together. So remember your order. Start in them inside and work out, okay? So W of 4, this is 4 acres. That's what that means, right? That means 4 acres. That takes care of that. And then we have M of 4, or M of whatever this is, would be what? What would that number represent? Money. Good, guys. Because it's M of whatever equals 20. So M is money. All right? So sometimes you have to, you just kind of have to dig a little bit. All right? Just dig in there a little bit to figure out what it's saying. It's not hard. It just can be confusing if you're not really looking at it. That's it for the notes, my loves. Let's go to the homework, which you probably will finish in class, even with all the knocks on the door. The other class is finished, and you guys always have a few extra minutes in this class because of Twitter TV. Okay, so here's the assignment, and I'm going to do the first problem has the most work in it. Number 2, And that's the only one of the first four I'm making you do. And I'm going to do it with you. After we get through number 2, it's smooth sailing. So I'm only going to talk, I'm only going to talk for a few more minutes. Okay, sorry, I didn't know that's what you're saying. I'm only going to talk through number 2, and then I will let you guys work on the rest of it. So stay with me, my little social class, and then you'll be able to finish. But let's do this first one together, please, because there's a few things in it we got to talk about. This is really algebra-y, like literally algebra 1 kind of stuff we're going to be doing. And I don't even think some of the things we've done this year, but hopefully you remember. But I'll go over it anyway. Okay, so question number 2. This is so mean when they do this. It's actually 3 parts, A, B, and C. Okay, so part A, let's do that one first. F of G. So we're going to take G and plug it into F, right? And because it's squared, I'm going to put it in parentheses. 2 minus x quantity squared, quantity means parentheses, plus 1. And I have to simplify that. That means I have to square this binomial, okay? Since I'm not using these other 3 problems, I'm going to use it for workspace, okay? So 2 minus x squared is 2 minus x written twice. And then FOIL, you might have learned it as distributive property. This is what I'm talking about going way, way back. I don't even think we've had to do any of these this year. But remember, 2 times 2 is 4. 2 times negative x is negative 2x. Negative x times 2 is, again, negative 2x. You're always going to get the same thing in the middle with these problems. And then negative x times negative x is positive x squared. You can combine the 2 middle terms and then put it in standard form, which is just exponents in descending order, okay? So that gets me, this right here becomes x squared minus 4x plus 4. But don't forget, y'all, there's a plus 1 at the end. So it will be 5. Your final answer here would be x squared minus 4x plus 5. Okay? So not difficult, but right? B, G of f of x. Take f, plug it into G. There's a negative in front, so I'm going to put my f of x in parentheses. So I would have 2 minus x squared plus 1. Simplify it. I would have 2 minus x squared minus 1, right? The negative goes to both of these. And then clean it up. 2 minus 1 would be 1 minus x squared, or negative x squared plus 1. It wouldn't matter. God, you can smell what they're cooking for lunch, right? It's strong. C. F of f, that's just taking f and putting it back inside of itself. So we're going to put all of what I have in purple in right there for x. So that would be x squared plus 1. That's my f of x. Right there means we square it plus 1. Go find some workspace. X to the 4th plus x squared. We're always going to get the same thing in the middle. Same thing twice, always, on these problems. X squared plus x squared is 2x squared. There's a 1 in front of those. So we just squared this binomial and got this. X to the 4th plus 2x squared plus 1. But don't forget, really easy to forget, there was a plus 1 there. And I have no more room, so I'm just going to write that as a 2. That would be your final answer. X to the 4th plus 2x squared plus 2. That's the most work you have to do, but there's one last thing I have to tell you because it asks for the domain. No fraction, no radical, no problem. We have no fraction, we have no radical, we have no problem. You can write your answer 3 different ways for the domain. The domain is all real numbers. The domain is negative infinity to infinity. But I want to show you one more, and that's this. X belongs to the element of all real numbers. This symbol here means element of. So F is an, I should have said it this way. X is an element of the set of all real numbers. This is just another way of saying just all real numbers, negative infinity to infinity. I don't care which way you say it. I just wanted to tell you this because you might see it again. X-E-R, kind of. X belongs to is an element of the set of all real numbers. Okay, so that's the worst one, and it's over. Let's get to work on the rest of them and asking for help if you need it. And I can't fit them all up here, so I will switch the pages in a bit.